Okay, so we're going to look at cycles. So we know that matter cycles, energy is not, and we require the recycling of nutrients, and this is referred to as biogeochemical cycles. We're going to look at the water, carbon, nitrogen, phosphorus cycles, and in this lecture, we'll do the first two. So just remember that the water molecule is polar. It's got a positive, negative end, okay? And that polar nature and it's covalently bonded, gives rise to hydrogen bonds between water molecules. And that makes them, provides them unique properties, excellent solvent, high melting boiling points, and very effective at energy transfer. And we also noticed from last set of lectures that ice is the least dense at 0 degrees. So expansion begins as the temperature decreases below 4 degrees Celsius. So it's the least dense at 0, and that's because these bonds separate further and water molecule expands as a lattice, as a crystal. Okay, so the hydrologic cycle is driven by heat, evaporation, precipitation, and we get that mostly over the oceans, but we'll also get it over land. And with the land, we also include with the evaporation of water through the stomata of leaves. So some key words that you want to be associated with this is transpiration, surface water, percolation, and leaching, and removal of soluble minerals by percolation. Acid precipitation, rain is slightly less than a pH of 7, and anything less than pH 5.6 considered acid. And this is primarily coming from sulfur nitrous oxides. SOX and NOx are called. When they react with water, they form sulfur and nitric acid. And what this does is it can kill fish in lakes. It can prevent the absorption of nutrients in roots. And it can also have devastating effects on beautiful buildings because these buildings are made of calcium carbonate and limestone. And this area shows where we're mostly affected. Big chunks of eastern Canada, the United States. And we've been able to put scrubbers and catalytic converters and smokestacks in cars, and this has reduced a significant amount of the nitrous and sulfur oxides. So acid rain is something that is being reduced because of those interventions. Carbon-oxygen cycle, remember carbon is the key compound for all living organisms, and photosynthesis is going to produce oxygen and fix carbon. And decomposers in the soils will return the carbon. And two key sinks, which are reservoirs, are oceans and forests. Fossil fuels are dead organisms compressed into fossil fuels. When it gets burnt, it releases carbon in the atmosphere. So carbon, coal, for example. So carbon's in the atmosphere. Photosynthesis is a key sink. Plants, algae, and cyanobacteria as well. And cellular respiration is a very short way of returning carbon into the atmosphere. So this is a very short cycle here. A longer cycle involves decomposition. Soil microbes will return it to the soil atmosphere as well. Think of your compost bin, will do that. But if these are taken up as coal, oil, or gas, they can stay in the earth for a very long period of time. Now, I mentioned photosynthesis is one of the key sinks. This diagram shows that the ocean is the other key sink. And what it does is it converts carbon dioxide into limestone and dolomite, which gets locked up for millions and millions of years unless there's volcanic action releasing it. Okay, greenhouse effect. Greenhouse gases, carbon dioxide, methane, water vapor, and ozone. Of the main, water vapor is by far the most common greenhouse gas. And what these do is they convert infrared into UV radiation rather into infrared. And if we didn't have that, our planet would freeze and it would not support life. So greenhouse effect is good. So what it does is high energy wavelengths hit the greenhouse gases, most of which is water vapor, and it slows it into infrared radiation, which gets trapped and heats up the planet, much like a greenhouse. Now, the enhanced is what's happened since the Industrial Revolution. We see that there's been, in a very, very short period of time, a lot of carbon dioxide being released from the burning of fossil fuels, mostly coal, okay? And that's a concern because it's associated with this phenomenon, climate change. Now, how scientists are interested in recording the ancient climate, and they do this by ice core sampling. And what this guy is doing is taking very, very fine slivers. The deeper you go in the ice, the older it is, way back to 800,000 years. And what they found is when they're comparing oxygen isotopes, 18 to 16, the ratio, they're able to then calculate how much carbon dioxide in the atmosphere, and they correlate that with temperature. And they see between the light and blue, there's a strong correlation between carbon dioxide temperature. What this graph also shows from 800,000 to the present is that there is a cyclical nature of carbon dioxide and temperature. Okay. In fact, before this was taken, temperatures have, they're considered to be about 400 parts per million today. So a very sharp spike in a very short period of time. But we know in the past they've been as high as 1,000 parts per million. Okay, mostly because of volcanic activity. Today, volcanic activity is not attributed to this. It's burning of fossil fuels. Okay, so here we can just quickly sketch this in, that this is sunlight energy. You're getting converted into infrared radiation. So this is my UV from the sun. Okay, this is the burning of fossil fuels leads to enhanced levels of carbon dioxide. So there's my carbon dioxide. And here's the two key sinks. Okay, so the two key sinks would be the oceans and the forests. Obviously, if we cut down the forests, deforestation alarming rate, we're going to cut off one of our sinks. If the oceans warm up too much, they're not going to be able to absorb as much carbon dioxide. So that's the other concern. Albedo is the other one that's interesting. Remember science 10, the reflectivity is albedo effect. Well, and we can see that things that have a high reflectivity would be snow, asphalt would have a very low reflectivity. Well, now let's link this to climate change. 1979, huge polar ice caps, okay? Lots of reflectivity. Withering away of the polar ice caps means there's more dark space and the sunlight gets absorbed. So this is what we call a positive feedback loop, okay? Which means that as the planet warms, it's going to warm even faster because more energy is getting absorbed and getting reflected in the poles. Now, ozone is a greenhouse gas, okay? How's it created? Well, ozone in the stratosphere, when it reacts with oxygen-free radicals in the stratosphere, forms ozone. And the UV, so the UV radiation actually can break down oxygen into oxygen radicals. But some of that oxygen then combines with O2 to form O3, 3 molecules. And then what that does is it actually blocks UV radiation. And UV radiation causes skin cancer. In the 1970s, it was discovered that CFCs are found in refrigerants and aerosol cans, okay? That these CFCs, which are really good at absorbing heat, okay, wafted up into the atmosphere and the chlorine dissociated and it started gobbling up the ozone. So there's far less O3 in the atmosphere. So much more UV radiation was coming in to create skin cancer. But remember that algae are a key photoautotroph. Well, if you kill off the algae, you're killing off half the oxygen producers on the planet. So it was a real concern. And we can see that in this diagram. 1979, very, very unnoticeable ozone hole. And now we've got a real thinning of the ozone layer over Antarctica. And you can read about the book, Why It Occurs in Antarctica and not other places. Well, since 1987, CFCs have been banned more or less, and the ozone layer is growing back. So there's a really good news story of how humans can intervene with environmental problems.